Hello all, welcome to the video lecture series for the subject operating system. Now I am going to explain you all about the fourth disk scheduling algorithm CSCAN, right? So we'll check whether this particular, the algorithm, disk scheduling algorithm is actually performing and increasing the throughput. Let's check, right? So this scan, that is CSCAN, is all about it against the discom is scanning the path and it's been scanned after reversing its direction. So here the difference between the scan and C scan is only one thing. So here it will start from the header and it will reach to the extreme point of this disk, that is 199, and again it will reach to the disk starting point, right? It is not about request, it is where this disk is actually started, that is started with 0, right? And then from it starts with 0 and then it will serve all the nearest request, right? So let me explain you in depth about how this particular point works. So here the possible way is to that is too many requests are waiting at the other end, or there may be a 0 or few requests pending at the scanned area. We are going to check how exactly it works, right? So this is the question is clearly given that 82 is 170, 43, 140, 24, 16, 90. This is the same example I have taken for previous three algorithms, and now the arm is at exactly 50, right? The same positioning, and the algorithm is different. That is the only difference we have. And also it is clearly given that this header will move towards the larger value. So what is the larger value here? If it is 50 and it is larger value is 83, 170, 140 and 190. Not, it won't move, that is left side value, that is 43, 24 and 16, because it is smaller values. We are always given, it is clearly mentioned it as larger value. It will always move towards larger value. Let's start. So the header point is at 50, and as you told you, this scan will take this 50 and that is a header, and it will exactly reach to 190, right? Now what are all the requests in between this? That is a point. We have the request at 82, so 82 is mentioned. We have the request after 82, we have 140, here it is 140, so we are going to mention it as 140. And see here, these are all the random numbers. You can mention 140 directly. So I have mentioned for random number sequence. That's why. So you can mention the exact same request also. That doesn't matter here, right? So here it is 140, and then the next request is 170. So here it is 170, and the next higher request is 190, and the header exactly stops here, 199. Right? So here the request is, again I told you, this C scan is all about whenever it is returning back to 0, it will not serve anything, right? And then from 0 it will start serve to the next nearest request. Say for example, so the header position exactly at 199. Now the header will take this journey and it will reach to the least number of this particular disk. The least number is the last where the disk is starting. Actually it is 0, right? It will reach 0 first. After that it will see what are all the requests we have. We have 16, we have that is 24 and 43, one by one, and it will reach exactly at 43. Now what are all the requests from, it will start 0 and ends at 43, and what are all the requests we have? We have 16, we have 23 and we have 44, right? Let's check. 1 2 3 4 5 6 7. So totally we have all this 7 positioning, and also this also we need to take, so we can mention it as 8 or random number, no issues at all. So we can mention this 6 7 8, whatever it is, 6 7 8 or 6 7 8 or 7 6 8, whatever, right? So here the request has been clearly given, and we have 3 positioning here, that is 50 to 199, 50 to 199, this is position number 1, and 192 again it is reaching some direction, this is called as second position, it is reaching number 0, and from 0 it is moving towards 43, position number 3. So we are going to calculate now how exactly this position is working, and whether it is comparing to the previous algorithm, whether it is giving the total covered by the discoms has been calculated which low latency or high frequent, high throughput, right? So let's check. Now here the total distance covered. So that is total distance which is covered by discom. DA stands for discom, that is equal to. So totally we can check it. 50 to 199, that is the first sequence. So I'm going to mention 199 minus 50 plus. Okay, this is the first sequence. Second sequence is I have already drawn here, and also I have explained you very clearly what is that sequence. Second sequence is between, sequence is nothing but where this particular header starts and it is exactly next reaching is at the end point of the disk. It is not ending anywhere here, it is ending here. In the path, whichever request is made, it is served. That's the point. It is not stopping anywhere. This disk is not stopping anywhere. It starts here, ends here. Again, it starts here, ends at the 0. Again, it starts here, ends at the last request call 43. So that is what it is. So sequence number 1, sequence number 2. What is sequence number 2? 199 minus 0. So 199 minus 0. And finally plus the third sequence. This is sequence number 2. Third sequence is, that is 43 minus 0. It starts with 0, ends with 43. So 43 minus 0. So what is the total answer we get? Around 149, 199 plus 43. So we have 391. So please check whether this particular algorithm is giving the that is total distance covered by the discom is minimum. Minimum in the sense the latency is reduced and throughput has been increased. That is what the point. So the final answer is 391, right? So this is all about total distance covered by a disk arm. So this is the position. So I hope you understand about how the C-scan is actually working with. The C-scan is the scan which is proposed to be optional between the scan and C-scan. Which particular scan gives more throughput, that is high throughput, will be taken into the operating system, which gives you much effective efficiency on this. So basically here the advantage is it provides the uniform wait time compared to SCAN. That's the point. See here, everything has been brought into the end of the disk, again brought into the position that is the first point of the disk, again it is ending at the last request. So here we have some kind of uniform wait time compared to the previous algorithm, that is SCAN, right? So I hope you understand this lecture. This is all about C-scan. Thank you.